Hi there, this is Robin Andrews from Computer Academy, and this is a video about graphs in Python for A-level computer science. Several of the boards require you to know about graphs. For example, in OCR and AQA, they're certainly going to come up. Also in CIE, they come up in the context of PERT charts and critical path analysis. So it's definitely useful to know about this. And having the power of this package behind you will really help to visualize and work with graphs in different ways. So I'm going to talk you through it now. Here we have a Jupyter notebook set up for this video. Now, in a recent blog post, I talked about Jupyter notebooks and how useful they are and how powerful they are. I strongly encourage you to explore them as a potential development environment. They are currently my favorite development environment. And yeah, it's up to you, but it's definitely worth giving it a look. A little bit of a learning curve, but certainly worth the effort in my opinion. So one of the things about these notebooks is it enables you to mix text. And this is actually in Markdown syntax, which if you're interested, I'll just show you. Markdown is just a way of quickly writing formatted text. So here I have these backticks. It's going to be displayed as code. And if I want bold, I use these asterisks, all that kind of thing. Yeah? And then we run a cell by Control Enter, and that executes what's in the cell, which in that particular cell was Markdown. So that's got nothing to do with graphs. That's just how these notebooks work, okay? And then we have this extension, which I love, which just formats my code for me. So if I'm typing and I miss out a space or I have too many lines between different parts of my code, it automatically just sorts that out for me. Absolutely not required, but very, very helpful extension. It does require a bit of installation. Very simple stuff using pip. And I've got another article on my blog about how to install stuff using pip. So, you know, don't be daunted by that kind of stuff. You really do need to be installing packages probably if you want to go beyond the very basics in Python. But that's that. So then we set up our basic graph. So we have to import the Networkx package. And we're using this syntax here, import the package as, and then the thing that we import it as can then be our alias for the name of that package, our shorthand for the name of that package. Yeah. So if I ever want to access anything from that package, I can just now call it NX. Okay. And then G, not a very imaginative title, but there it is for my graph. And if I create a graph, it starts off being empty, so that if I print it, if I click in here and then run the cell, you can see that there's no nodes and no edges. Okay, so you get these empty lists here showing that. That's the initial setup. Then moving on to nodes. Very simple syntax, really, very intuitive. If we want to add a node, we just add it and we give it a title. You can use integers as well as strings. I prefer these strings really because it makes a distinction if I do have numbers for the weights, for example, on the graph. It makes it clearer for me. So I like to use letters for the names of my nodes. So now once I've added A and I run that cell, you can see my graph now consists of a single node called A. Okay. That's how you add a single node, but if we want to add multiple nodes, you can add nodes from a list of nodes. So here there's two more within a list. Again, if I add them using add nodes from, then you'll see here the result of that. Also displaying the number of nodes in my graph, okay? So it's all very intuitive language. It's a great package and makes things very simple with graphs. Then we come on to edges. So if you want to reset your graph, you can just use this clear command. So you can have a fresh graph to work with. So I've cleared my graph. Then now I've added all three nodes at once, A, B, and C. And now I'm adding some edges. So for example, here I'm adding an edge between A and B, between nodes A and B. And I'm also attributing a weight. Now you don't have to use a weighted graph, but it's certainly worth being able to do so. So I included that in this example. And that's basically how that works. So we add our edges, we add a weight if we want to. You can actually assign any property here. This isn't a built-in thing, the weight. It's a variable name that I've created myself because I want to keep track of the weights. Okay, and then I can access those later on, as you'll see. And then if I get to the end of that and print that cell, you can now see what the printed representation of my graph looks like. Okay, so we've got our nodes. And then we've got a list containing our edges. Okay, so hopefully that makes sense. Got three nodes, and we've also got three edges. So then we come to the fun part, drawing our graph. Now, there is a brilliant library called matplotlib, and it has a sub-library called pyplot, which is excellent for simple graphing. Some very powerful features. And this code here is going to enable us to plot our graph. Okay, so let me just talk you through it a little bit before I run it. Okay, so pos here is a way of keeping track of the position of the nodes. Okay, so it uses this thing called spring layout, which is basically a random layout for the nodes. You can, in theory, hard code the positions of the nodes, but it makes sense to me to use this kind of built-in function. But we need to keep track of where those nodes are. So what this does is it creates a list of where they're going to be. Okay, and then the weights is here. It's grabbing the weight attribute from up here, the attribute that we defined ourselves. Okay, so that's creating a list. So pos is a list and weights is a list. Okay, a list of positions, a list of weights. And then we have these two statements. We have draw the network. So G is the name of the graph. Sorry, not draw the network, draw the graph using Networkx. G is the name of the graph. Pos is the list of positions. Okay, and we're just saying here that we want labels. Yeah, we want to actually see the name of our nodes. And then we come to actually drawing the weights. So draw network edge labels. Okay, so that's going to label the edges. Again, same graph, same positions. And the edge labels are going to be weights, which again are the ones we defined here, as I've explained. So that's it basically. Then we just give it a title, and then this, I've just given it an empty string for the figure name, because if you do this outside of Jupyter Notebooks, you get this annoying figure 1 unless you put this in. So I just put this in so I don't have a random figure 1 on as my window title. Finally, plot show actually renders all the stuff that we've created for our image, actually draws it for us. Okay, and you can see again plt is an alias for matplotlib.pyplot. Okay, it's just a shorthand, a handle if you like, for that package. And this is a standard convention. We often use PLT for this particular sub package. Okay, so let's see what it does. And as if by magic, okay, you can see we've got our nodes connected by our edges, labeled with our weights. Okay, the title here looks a bit odd because I've got this dark theme going on in my browser, but it says basic graphs with Networkx. And that's really probably enough to be going on with. If you want to definitely, write this code for yourself, I don't recommend copy and pasting. I recommend actually typing it in yourself. That way you kind of remember it better, you understand it more deeply. Play around with this code, create your own graphs, and then in future videos I'll show you how to do things like Dijkstra's algorithm and different algorithms that work with graphs. But it's definitely a good idea to get familiar with this very basic behavior of the Networkx package before diving in much deeper. Okay, so there it is. That's Networkx and how to draw a simple graph using Python. Thanks for watching. See you next time.